Hello guys, so welcome to this course, Data Structures and Algorithms. So first topic will be linked list. So what's a linked list? A linked list is a linear data structure where each element is a separate object. Like you see these rectangle boxes with two spaces inside, these all are separate objects. They're not actually like continuously stored, but they are stored in different locations, and each are connected using the pointer values. So each node of a list is made up of two items. It may not be two items, but if your structure definition has two items where each is, like for example in data means one data where you can store integers, and the next will be a pointer. The last node has reference to null. Okay, so what it means is the last node, the second part, instead of storing the value of the next node, it will store null so that the compiler can know that the linked list has come to an end. So in this linked list of A, where a variable is a value is stored, the second part, that is the next part, will be having the value of this node which has the B second storage place will have the memory value of C. So it's like if you want to access B, you have to go through A, which will connect you to B, and you need a head node so that you can get access to all these nodes. So head node will be pointing the starting of the variable, and this variable will be connected to B, this will be connected to C, and this will be connected to D. So it's like, that's why it's called linked list. It's all linked. So this is the theoretical part. Now let's move on to the implementation part. So now let's start our coding. So I will put the header files. You can pause the video and try practicing on your own so that you can have a better understanding. Now I'll make the structure definition. So now I made the structure definition. Now I'll be able to store a value of the data type in, meaning integer, and the same node will have the second part, which is a pointer value because you're storing the address of another variable. Now what I'm going to do is, now I'm going to make a head that's gonna point to null. So what happens here is, here a head, see star head equal to null. So what happens here is that you make a head node, and now it's gonna initially point to null. So what this indicates is that it says the compiler that there is no elements added to the list, basically an empty linked list. Now we can create the function to insert and a function to display the elements we have entered already. Now we can make a main function here, insert to let me change the values, 6. Now make the output statement So now we have made a main function to insert these three objects and the display function to display the elements we have inserted. Now let's complete our insert function. Okay, so we'll make our variables struct node star underscore node is equal to new node. So this is the syntax in C++. In C it's going to be slightly different, a longer sentence, but let's stick to C++. And we'll make another variable called struct node star current. I'll explain you why we make the next variable. Now let's see what happens till now. So when we call the insert function, it's gonna come to this function, and now struct node star new node is equal to new node. So what happens here is, so it makes a separate node where the left part will be the data and the right part will be the next, which is a pointer variable. Now let's move on to our code. If head equal to null, so why we are writing is that initially we have done that head is equal to null, so which means that the list is empty. Now when you're first inserting a value, we are going to need this statement. Let's see what's going to happen next. So I have done the code here. So what it says here is that when we call the function insert 2 and the argument is value 2, it goes here. Now it creates a new node, and new node tends to data is equal to new node. So what happens here, the value 2 will be stored here, and new node tends to next will be null. So now this will be made null. Now head is equal to new node. So we have said here head is equal to new node. So head is equal to new node means this will be erased. This will be erased, and now this will be pointing to this node. And now we need it said that current is equal to new node, so we make a new variable called current. Now that will be also equal to new node. I'll tell you why we are using the node current. I hope you have understood till here. If you're not, please rewind and see the video again so that we can get a really good idea of what I'm telling right now. Now next, insert 4. So now the head is not equal to null. So what we have to do, we have to write the next part of the code. Now the second function is called, it goes here into the function, and now a new node will be created. Now a new node is created, but now the compiler won't go inside this function because now head is not equal to null anymore. See, now head is pointing to the node which has value 2 stored in it. Now instead of that, it goes to the next function, new node. This new node which is created now, data will be equal to new data. So what we have passed 4, and now new node tends to next equal to null. So this will be tending to null, and current next equal to new node. So what we see here is that current is pointing to this previous node. Now current tends to next, which means current tends to next means it is meaning this part. Current tends to next is this part will be equal to new node. So this part will be equal to the new node. Get it? Current next is will be equal to new node, and current is equal to new node. So now the current, so initially current was pointing to this node. Now current is equal to new node. So this link will be erased, and now this will be pointing to this node. So I guess you get to know the use of current node. So current node is used so that you may get an opportunity, or you make a way so that you store the previous node's address and now use it to the new node and point it to the previous node. So now you get one link is attached. So now let's complete the next node. Now I'm calling the insert 6. So insert will go here, insert 6, the argument 6 will go. Now I'll create a new node with, so this will be the data part and this will be the next part. The value 6 will be stored here, and it won't go into this function because head is not null. And the new node tends to data is equal to 6. New node tends to, so this is the new node. Okay, just remember this will be the new node. This tends to next. This will be the next part, will be null. Current tends to next part. So now current is pointing here. So current's next part, that is this part, will be equal to new node. So this will be the new node, and current is equal to new node. So you see that now when you say current is equal to new node, it's gonna come to, it's gonna store this node's address in it. So now current is traveling from here so that you can get the previous node's value and store it to the current node's value. I hope you have understood till here what is happening. So basically what has happened here is, this is what has happened. You create a head node, it's initially pointing to A, so this, instead of A it will be 2. Now it points to 4, and it points to 6, and we don't need this right now, so I'm gonna delete this 1, and I'm gonna point it, so this will be equal to. Now let's go on to the display part. Now we'll work on the display. So struct node star pointer. Now we are going to make this pointer equal to head. So what happens here is, so here we see we make a pointer, a new node pointer, and this pointer is equal to head. So what basically means is that head is actually pointing to the first node of the linked list. So pointer equal to head means now pointer will also point to the first node. So now we have a variable which is pointing to the first node. Now if we get access to the first node, we can get access to the rest of the nodes, right? So now here's the next statement, while pointer not equal to null. So in now pointer is anyway not equal to null, so pointer not equal to null, it goes inside this while loop. See out, pointer tends to data. So pointer is pointing to first node. What is pointer tends to data? Pointer's data part is 2. So now cout print pointer tends to 2. So now in the output array it will be 2. Now there's a space, pointer is equal to point next. So now this pointer will be pointer next. What is pointer next? This is pointer next. So if address of the next node is 102, here 102 will be stored. 102 will be stored here, and pointer equal to pointer next means this link will be closed, and this would now point to this. So pointer is replaced by pointers. Initially it was pointing to this node, so pointers next. So pointer is now pointing to 4. Now still it's in the while loop because pointer is not equal to null. So now cout print pointer data. So pointer data. So what is the data? This is the data. Now 4 will be print. Now this pointer is equal to pointers next. So now pointer is pointing to this node. So pointers, let for example arbitrarily take 104. Here 104 is stored. Pointer equal to pointer next means this link will be cut, and this pointer will be pointing to this node. Now again it goes in the while loop. Now pointer is now equal to null, right? So now pointer is pointing to this node. Now pointer cout pointer data. So pointer is tending to this node. This is the data part. So data part will be printed. Pointer is equal to pointer next. So what is pointer next? Pointer next is actually null. So now pointer equal to pointer next will be, it will be equal to null. Equal to null because null is stored here. This is the pointer's pointer next part. So pointer tending to next will become null. So now this will come out of the loop because pointer is now equal to null. So this is a complete code on singly linked list. So I guess now you would have perfectly understood the concept. Now let's compile and see what it says. Says the linked list is 246. Thank you guys, and please do subscribe and like this video so that I may get motivated to do the next upcoming videos. Please do support me guys. Thank you. See you in the next video.